Okay, the idea of a limit of a function is what connects algebra and geometry to the mathematics of calculus. In working with the limit of a function, we encounter notation of the form we see here. And this is read the limit of f of x. So the limit f of x as x approaches c, which is some constant, equals the number n. So n is the number. All right? F is the function defined on some open interval containing the number c. The function does not have to be defined at c. Okay? Another way to describe it is as x gets closer and closer to c, right here, as x approaches c, but remains unequal to c, the corresponding value of the function f of x gets closer to n, the number. Okay? And we're going to use tables in this video. I have 11 examples. I suggest that you use a calculator and do the video for the examples I have and pause the videos. The first one I have is a popular one that you should know. The limit of sine of x over x as x approaches 0. So it gets closer and closer to 0. So basically we're going from the negative values of x, and this is without a graph, so we're just looking at a table. We want to see where it changes from negative to the positive. And if you look at this, right in here, this gets closer and closer to 1. These numbers here are very close to 1. So the limit is x of sine of x over x as x approaches 0 equals 1. There's a very complicated hard proof on this that you can look at as well. But looking at the table is very easy. Okay, the next one we have. Oh, by the way, I'm not going to write down the whole table to look at. I'm going to only look at the place where it changes value. So you really need your own calculator to see the whole table. Excuse me. This is the limit of 4x cubed as x approaches the constant 2. So as we get closer and closer to 2, this is 1.999, and then we go to 2.001. So 2 is somewhere in between here. And if we look at these numbers here, this gets closer and closer to 32. So 32 is our answer. And I'm going to go a little faster here. We want to know limit of 2x squared plus 1 as x approaches 3. So we get closer and closer to 3 without touching it. And the y part gets closer and closer to 19. So the value is 19. And this one, you look at the table, this is very close to 0. These numbers here, it's from the negative side and the positive side. And this gets closer and closer. This is very close to 1. This is very close to 1, so our answer is 1. All right? The limit of 2 minus x divided by x squared plus 4 as x approaches 0. So here's our zeros amounts here. It gets closer and closer to 5. So that equals 5. Number 6, you just plug it in the calculator. We're looking for x as it gets very, very close to 4. Very close to 4. This one's a little less than 4. This one's a little bigger than 4. And the y portion is the same, so our answer is 4. Number 7, it's very clear what the limit is. It is 2. We have getting close to 3 from the left, the lower bound, and a little over 3 here. So our limit, our answer is 2. Okay. This one is the limit of e to the x plus 1 as x approaches or gets very, very close to 0 without touching it. And when you look at this, that's getting close to 0 without touching. And these two are very close to 2, so our answer is 2. The next one is the same thing. This is as x gets closer and closer to 0. And this basically is very close to 0. So the answer is 0. Same thing for number 10. You put that in the calculator and you see the answer is going to be equal 0. And on the limit of tan of x over x, as x approaches 0, you look at the table and it's very clear that the limit equals 1. The next video is the graphs, which gives you more of a visual feel of limits. And that will be the next video.